All right, so system of linear inequalities. You're going to have two or sometimes more. We're going to see a couple, one today, but more tomorrow and the next day that have more than two. Today we're just mostly going to deal with two equations, or two inequalities. But when you're graphing this, you want to think of the lines being, should they be dashed or dotted or solid? So you want to think about that for the lines. You want to think about your shading above or below. And if you have a system, what we're going to look for is any point, let me put points because usually it's a region, any points that satisfy all inequalities. Basically on the graph, what that's going to be is where your shading overlaps. And that'll be a little bit more evident when we actually do that on the graph. So anywhere where your shading is going to overlap is going to be the solution to your system of inequalities. All right, so as you graph these, just one thing for yourself. As you go through, I just do one at a time, and I just kind of lightly shade on each, and then I figure out where the overlap is and kind of darkly shade that in. So let me just go down to this first system here. I've got the first inequalities right there for you in standard form. So it would just be like graphing the line y equals negative x minus 1. If you could graph that line, you can do that first part. This says y is greater than. So this is just going to be a dashed line. And if y is greater than, I'm going to shade above that line when I do my shading. So I'm just going to come down here to the graph. Just go to negative 1 on your y-axis, y-intercept, right? My slope's negative 1, so I'm just going to go down 1 over 1. And I'm just going to kind of just do my best to draw a dashed line here through this. It doesn't have to be perfect. Okay, now as I do these, I just kind of lightly, not real dark, I just kind of lightly shade for myself. So greater than goes above. If you're not sure, put your pen, pencil, whatever you're working with directly on the line. If you're going greater than, above, just draw straight up. So I'm just going to kind of lightly shade. This would be all the points that would satisfy just that first inequality in the system. All right, let me grab a different color. Okay, now the next one, if it looked like it would have nice intercepts, I might do that. But 9's not divisible by 2, so what I might do for that second inequality, I would just get y by itself on one side. So to do that, just going to remove the term with the x, so it's positive 2x, I'm going to subtract that. Now I've got negative 3y is greater than, and I'm just going to place that negative 2x right after the inequality symbol and just kind of shove the 9 down. That 9's positive, so when I shove it over, I'm just going to put plus 9. Okay, to get y totally alone here, I got to divide by the negative 3 that's in front of it. And do I want to remember anything here if I'm going to divide by negative 3? Yes? Yes, don't forget, we're going to flip the sign over anytime you divide or multiply by a negative. So that's actually going to turn out to be y is less than. Now, that in front of the x, you got a negative 2 over negative 3. The negatives are going to cancel. So I would just leave it as a fraction, though, because that's like your slope, right? So just 2/3 x, and then positive 9 divided by negative 3 is negative 3. This guy is, again, going to be a dashed line because it's just a plain less than, and less than goes below. So I'm going to shade below this line when I put it on my graph here. So I'm just going to go down negative 3 on my lovely y-axis. And my slope rise over run up 2 and then over 3 to the right. I'm just going to do a couple points. All right, again, this is a dashed line. And let me scooch that up. I don't have that on the page very well. All right, now for that one, I would shade below. So just kind of ignore the other graph, just lightly going to shade below that. If you're solving a system, I have to work for both of those inequalities. So I got to be above the pink line that I drew there, but below the purple line. So hopefully you guys can see the overlap where both is going to be right in here. So this is going to be the region where all the points work for both inequalities. And I just, like I said, I just kind of shade lightly for each, and then I just shade darker over the actual solution. So all the points that would fall in that shaded area, and you can see, I mean, I went way off the graph there on my picture, but any point that would fall in that region. So a couple of these questions are going to ask you, like, give me an example of a solution. And so literally all you would have to do, just pick any point. Like, I'm just going to randomly put a dot on a point in that region. I put my dot, like on mine, on 7, -3. So if it asks you to give an example, you literally just grab any point that falls in that shaded region. Does anybody have a question? Okay, let's try one more. You guys try this one. I'll just do it up here really quietly, and you guys go ahead and do it on your paper, and we can check. Now think about when you graph the inequality, should it be a solid line or a dashed line, and then should I shade above or below? Make sure you ask yourself both of those questions. And like just want to shade where their regions would overlap, because the overlap is going to be where you satisfy both inequalities here. And I'm just doing it kind of on my paper. And then if you're feeling good, just write an example of a solution. And everybody's could be totally different. Does anybody have a question at all? Somebody tell me their possible solution. What'd you write down as your point? Eli, what'd you put? Perfect, -2, 0. Any point that's in that shaded area. Is anybody having a question? Okay, now at the bottom, all I'm going to do in this example, we're just going to work with horizontal and vertical lines here. So the first one, now shade above or below does not work with the vertical line, which is what we're going to have in example 2 here, the first one. So if you have a vertical line, I call it vertexal because it's x equals a number, and all the points on that line are going to be with the same x coordinate is how it works. So this just says x is greater, bless you, x is greater than or equal to 2. So I know this always trips people up because it's parallel to the y-axis, and I don't know why I just drew a dotted line, but it should be solid. So greater than or equal to 2, which just means all the points on this line would be part of our solution, but I can't shade above or below a vertical line. So you got to think about it for a second. It's either going to be right or left. Where are my points greater than or equal to 2? Is it on the right side or the left side? The right side. So I'm just going to lightly, so it would be all these points over here would satisfy that first inequality. Now, the second inequality says x is less than -3. So -3, nice vertexal line, but it should be dashed or dotted, however you want to say that. And if my x coordinate is less than -3, would that go on the right side or the left side? Left, because your x coordinate, like we're less than -3 going this way. Okay, what would I write as my solution there? They don't intersect. Those two shaded regions don't intersect. I can't have an x coordinate, think about this for a second. You can't have an x coordinate bigger than 2 and less than -3 at the same time. It's not possible. There's no point where that exists. So this guy is actually going to be no solution. So if that happens and your shading areas for both don't overlap. That's possible. We don't have a solution there. All right, we will have a solution for this one though. So I have a nice horizontal line at 5. This is going to be a dashed line. So all the y coordinates are 5, just this nice horizontal line kind of close to the top of that graph. And it says my y coordinate is going to be less than 5. Now above below works here, so I'm just going to kind of lightly shade below this line. So I need a y coordinate smaller than 5 and an x coordinate greater than or equal to 0. Now I know this is weird, but x equals 0 is actually the equation of the y-axis. So that's where all the x coordinates are 0. The y coordinates change as you go up and down, but the x's are all the same there. And so I am supposed to be, y coordinate is less than 5, x coordinate greater than or equal to 0. So any points on that line would be part of our solution. So if you guys can kind of tell, the overlap here is going to be kind of like this rectangular region. And it would go off the graph. I don't have the whole graph of everything that's possible represented here, but kind of that region. All those points have an x coordinate greater than or equal to 0, and at the same time have a y coordinate that's less than 5. Is anybody having a question? Actually, let me ask you a question before I flip this over. Would the point 0, 5, I'm going to say, is 0, 5 a solution here? If you looked at that, would you tell me the point 0, 5 is a solution? Good deal. Yeah. Okay, so it would work. It looks like it works for both, right? But it's on that dotted line, so that's not going to work for one of the inequalities in the system there. So that would not be a point. It almost looks like it should be, but it's on a dotted line, so it can't be. And that y coordinate would be equal to 5 there, so that would not count. So that's not a solution there. Okay. All right, see what you guys remember from the first unit about our lovely absolute values. I'm going to have a couple absolute values on this graph, and I maybe was a little enthusiastic with how giant this graph became on the paper, but we don't need all that space probably. All right, so let's just do one at a time. All right, so my first inequality, which is y is greater than, so it's going to be a dashed line here. Now, I see an absolute value, and I should think of what shape? I see an absolute value. E, right, okay. Now, does anybody remember how to find the very middle just by looking at the inequality here? It would be just like you would find it for an equation. Yeah, Gabe, go ahead. Perfect. Okay, inside the absolute value, and this works for every single type of graph, not just absolute values. Inside with the x, opposite of what it looks like. Outside, you're going to copy. All right, so that's going to be my vertex. So go ahead and find that point. Okay, now, looking at that inequality, it says y is greater than negative out in front of that absolute value of x minus 2 plus 4. How would you find, like, the two sides of the v? How would you graph that from there? Like, what is going to indicate to me how I would find other points? Yep, negative, right here. That's going to turn it down, right? That's a reflection. It flips it over. Just go down 1 over 1 on either side of that vertex. Just down 1 over 1 either side of that vertex. Okay, now I'm just going to kind of do my best. This should be a dashed line. And I'm just going to lightly shade this as y is greater than. So the shading here would be like on top of this. So just kind of going to lightly shade because my actual solution is going to have to satisfy both of these absolute value inequalities. Okay, now our second one says y is less than or equal to, so I immediately know we should have a solid line here. And it's 2 times absolute value of x plus 1 minus 7. Can anybody raise your hand and tell me what the vertex of that absolute value graph would be? What would be right in the middle? Eli, what do you think? Perfect. Okay. -1, -7. inside with the X, opposite of what it looks like, opposite copy. And so let's find that point here real quick. Okay, kind of towards the bottom of the graph there. All right, now, how would I find other points to make my V shape on this graph? Yeah, okay. This should turn up. There's no negative, so it should be a right side up V, but it's got a 2 in front of that, so that's just like your slope. So just on either side of that vertex, just up 2 over 1. You do a couple. This guy's going to be a solid line. And we would go less than here. So less than would shade below that. Okay, now, if I got to satisfy this system, I got to work for both. And this might be a little bit harder to see. There's actually 2 different regions on this graph that I'm going to shade. So I've got to be above the one I did in pink and below the one I did in purple on my paper here. So right here, if you guys can see that, that's above the pink line but below the purple line. So kind of this area would work for both, all these points. And then also, if you guys can kind of slide, I'm going to slide my paper over just a teeny tiny bit here, above the pink line but below the purple, or yeah, below the purple line, this over here. So, and that can happen. You might have a couple different regions that satisfy both inequalities. So any points, I could grab any, as a possible solution, I could grab any point here, or I could grab any point here. So there's actually 2 regions, and you might see that on a couple of the questions on homework today. Does anybody have any questions? Okay. Now, our lives would not be complete without a word problem, so here we go. This is not bad, I promise. And I can see that I made this typeface too big, so we'll just have to zoom out, sorry. Okay, so it says, Adam and his children went to a restaurant where they sell hot dogs, $3 a piece, tacos for $4 a piece, and he has $60 to spend. Let's see, he's got to buy at least 12 hot dogs and tacos together, and he can't buy more than 10 hot dogs. So I've actually got several different things going on here. All right, so as I mentioned to you guys, money goes with money. So $3 for the hot dog, $4 for the taco, he's got $60. That's going to be one inequality. All right, he's got to buy at least 12 hot dogs and tacos together. That's going to be another inequality. And then he can't buy any more than 10 hot dogs. And just so we all had the same thing, I just wrote here, X represent the number of hot dogs and Y represent the number of tacos. So X is hot dogs, Y is tacos. All right, can anybody write me the inequality that would go for that first thing I highlighted where it's $3 each for the hot dog, $4 for the taco, and he has $60 to spend? Perfect. 3x plus 4y has to be less than or equal to 60. So what he's going to spend is going to be on the left side of that inequality. He only has $60 to spend, so what he spends has to be less than that. Okay. The next one I think is kind of tricky. So it says he has to buy at least 12 hot dogs and tacos together. How would I write that? I got to buy at least 12 items, basically, is what I'm saying there. How would I write that? Yeah. Exactly. Nothing to do with the money. Just X would be your number of hot dogs. Y would be your number of tacos. And I need at least 12. So what I'm going to buy has to be greater than or equal to 12. And I've got one more here. And that's just what says he can't buy more than 10 hot dogs. How would you write he can't buy more than 10 hot dogs? X is hot dogs here. Yes. So this one doesn't even involve the y. Just X can't buy any more than 10 hot dogs. All right, so this is going to be 3 inequalities here. Now, in this case, here's what I would recommend. I would recommend using intercepts. So for this first inequality, if I just take, remember you can take your, cover up your y if you want to find your x-intercept. X-intercept just means y is equal to 0. If I just take 60 and divide that by 3, that's 20. So for this one, that first inequality, it's going to cross the x-axis at 20. Where would it cross the y-axis? Anybody know? Where do you say? 15, right? Just cover that up. 60 divided by 4 is 15. Okay, now this is going to be a solid line. We're not going to go out of the first quadrant because we're not going to sell or buy a negative number of hot dogs or tacos. So I'm just going to play connect the dots there. All right. Now, the second inequality we wrote down was just x plus y is, now I got to be less than this line. So we're going to shade below here. I'm just going to wait on that for a second. The next one I'm going to shade above, x plus y is greater than or equal to 12. What would your intercepts be for x plus y greater than or equal to 12? They're both 12. I love equations like this. This is going to be a nice diagonal line. X would be 12 and y would be 12. That's all you got to do. All right, they're not parallel to each other. They're just a little bit, their slopes would be different. The slope of that first inequality, if we actually graphed it, would be 3/4, and the slope of that second inequality would be, or sorry, negative 3/4. The slope of the second inequality would be -1, so they're not parallel to each other. But at this moment, I would be less than this lovely pink line I drew, greater than this purple line. So at this moment, I'd be in between these two. Now, I've got a third inequality here that says he can't buy more than 10 hot dogs. All right, so that's just going to be a nice vertexal line right here. And less than, if you got a vertical line, less than is going to go to the left. So at this moment, I'm smaller than the pink line, greater than the purple line, and less than to the left of the blue line. So the overlap of combinations here would be in between here. So any of these points would represent a possible solution to the system here. And where these intersect, I can use all of these because the lines are all solid on this. So, for example, oh, I hope I did this right. This looks like the point, oh, what is that, 10, 7. This is the point, 10, 2. Those would be possible solutions. Your intercepts would be possible solutions here. So I had 0, 15. I had 0, 12. Any of those would be possible solutions there because all our inequalities were either less than or equal to or greater than or equal to. So all those intersection points, and then any point in the shaded region would also be a possible solution. So you could pick any point in there, and that would represent what's going on in this inequality. Is anybody having a question?